Hello, my name is METİN ARIDAŞIR. This is 22nd part of explanation of my theory. This video is continued part of 21st part of my theory video. Remember 21st video. This is, I'm so sorry, immersed. This is my blackbody radiation plotting according to my theory and my formulas. For each degree between 90 degree and 0 degree. Here, from 90 degree to there 0 degree. This is the main theoretical predicted original blackbody radiation or all of continuous spectral graphs main original graph according to my theory and my formulas. X-rays, continuous spectrums, and it is not important whether applied voltage or under the effect of temperature. It is not important whether from astronomical observations from high wavelength, micrometer level wavelength, continuous spectrums, blackbody radiations, or so small X-rays, continuous spectrums. This is main graph. Blackbody radiation's real graph is that. Then if we connect all of hills of points, this is the roughly blackbody radiation graph. Original graph here. This is on this graph. If we connected the points, upper points, this is the shape, blackbody shape. Okay. In 1880s, in 1980s, and in our time, because of scale and measuring and sensor problems, blackbody radiation graphs had drawn roughly and approximately. Then had been tried to find formula respect to this graph. Max Planck had tried to solve the problem. But that shape was roughly shaped and theory was wrong. Their theories was wrong and still main quantum theory formulas is wrong. All of blackbody radiation or continuous spectrums, graphs, shapes, source is unique source. Electron or electron-like motion form, which is relocating. Relocating electron motion form. Metasensation perception matter has intrinsic motion forms, and main intrinsic form that I know, I guess, is, and I determine, and I put forth, intrinsic electron motion form. I have told you before. Here, our electron motion form. You know, this white page is our metasensation perception matter. Once upon a time, it was an empty page for me that I have started to write. This is a sphere. This is a sphere. Okay. There is a leak, or there was a leak. This electron motion form at a certain velocity, say 238,650 km per second, come in, closed, here. It is going on relocating at that velocity. That velocity, how it gains it? By applied, for instance, applied voltage equal to 20 keV in this sample. And I have drew this graph with these data from my another formulas and from my another computings. Say, for instance, at rest wavelength of this relocating electron, lambda n, initial lambda, is 0.3 nanometer. Then, if we applied it 20 keV electric potential, it gains 238,650 km per second velocity. Okay, and in this direction, 0 point direction, it's relocating direction. Okay. While relocating, its successive waves, we know, will change. Each point, each degree, in each degree, here, here, here, say 35 degree, okay, say 60 degree, etc. At that point, in this sphere, remember 21 video, in this sphere, at the same time that all of inner surface of sphere is detector. Okay. All of free electron motion forms waves when touch this inner surface of this sphere. Detector is signaling and read the energy. Okay. Because of, according to these operations, here energy in EV wavelength. Okay. But this wavelength from 0 to eternity. Don't confuse E, energy, or say intensity, but I will say energy now. Different formulas. Okay. I computed by my formulas for each degree wavelengths and energies, and I plotted like this. But I started, this is 90 degree, this is 0 degree, okay? From 90 degree, here, projection, wavelength point, but parallel degree, 89 degree wavelength, lambda, okay? And here, I'm so sorry, I will go on with that. Another wavelength point, 88 degree, 87 degree, okay, projection. Okay. How did I plot it and compared this graph? I will show you now. How did I compare? How did I compare? And how did I plot? Okay, don't forget this. We will find what? We will find here wavelength lambda alpha. Remember, what was lambda alpha? Lambda alpha is lambda n minus delta lambda cosine alpha. We will find this for each degree, for each angle. Okay? Now, then, according to this, we will find energy corresponds this wavelength, and alpha hc divided by n squared lambda n minus delta lambda cosine alpha. Okay, first we will find this n, wave number. How can we find wave number of this wavelength? Because of wavelength are changing. Okay, now step by step, please. I try to tell you my whole theory, my whole concepts, and my whole formulas, step by step. And I will do that. Okay? Wholly, I will tell you all of my theory in time. Okay. Remember, it was our sphere. Okay. Here, the free electron motion form at this velocity, applied voltage, and its normal at rest initial wavelength is 0.3 nanometer. Okay. At the center of sphere, just in that point, it's going on. Its motion, it may be in motion, not in inertial situation. It may accelerate. It may be accelerating situation. It may deceleration situation, but now inertial position. Okay. For easy accounting, computing. Don't forget, this is 0.3 nanometer lambda n. And say, for instance, these spheres, closed spheres, which all of inner surface is detector. For each point, it can detect energy. It can measure energy. Okay. What is radius of this sphere? This sphere's radius is, say, 0.9 nanometer. Here, 0.9 nanometer. Okay. Now, our aim is finding number of wavelength which will arrive that point because of at this point electron motion forms successive wavelength different. At this point its wavelength different, and at this point 90 degree lambda n, and here its velocity, remember, c, not change, and each successive wavelength is not changed, lambda. Okay. Now, at this point, how many successive waves we need to arrive at that point, this wavelengths? Okay. This is the distance is unchanged. Okay. We know light waves speed changing. Okay. Light wave speed is changing respect to direction of relocating electron motion and velocity. Here we say d c minus electron motion forms velocity cosine alpha wave velocity is different here, different here, different here, but arrives at same time, but wave numbers are different wave numbers. Here, if from this point and to this point, in the direction of 90 degree, 0.3 nanometer wavelength, electron motion forms successive waves, 1, 2, 3 paces, okay? If a certain time interval, 1, 2, 3 paces, okay? 3 number, its number is 3 and velocity d equal to c, okay? This is my main formula, okay? Now, I will explain this ratio. My another formula, okay? Remember, at this point to 90 degree, d equals c here, okay? D 90 degree divided by d alpha, maybe this, maybe this, maybe this, maybe this, equal to, this is my, don't forget, formula, okay? And say an alpha, except 90 degree, each degrees maybe, okay? Which one will? D alpha, say this, okay? And it means waves from that point to that point to arrive needs n number waves, successive waves. Here, then divided by 3. Why? Because of, for instance here, 0.9 nanometer, okay, 1, 2, 3, here, 3. If at this point, from this point to that point, successive waves numbers is 3, and at this, in this direction, 90 degree direction, equal to c, okay? Don't forget this. Okay, at this point, this is my relation formula. You multiply it by this, equal to multiplied by this, okay? C multiplied by 3 equal to d alpha, we can find d alpha, multiplied by n alpha, okay? From here, we can find number of waves that we need, that successive wave needs to finish this travel, okay? Again. Our first purpose is finding number of waves, so important. Again, here D 90 degree equal to C, okay? For instance, for 3 phases, for 3 number of wave, starting here, finishing there, okay? When finished, it's traveling 0.9 nanometer distance with 3 number of waves. At speed of light because of 90 degree, okay? If it does so, say 35 degree, D alpha, D 35 degree, we will find easily, okay? And 90 degree equal to here 1, 2, 3, okay? Because of 0.3 multiplied by 3, 1, 2, 3, finish 0.9 length of distance, okay? Here 3. I beg your pardon. I'm so sorry. Number of X, here, number of 35 degree, number of another angles, changing, number of waves will change, okay? Velocity of the light change, wavelength of the light change, velocity of the light change, number of waves change, okay? And number of 90 degree. Number of 90 degree we computed is here 3, okay? This is C, this is 3, okay? 300 kilometer per second. And our aim is finding this. In 30 degree, how many numbers we need? 35, say 35, it's nothing. Yes. 35 degree, like, okay. Say 35. Yes. Now I will look for my computing. Here. $35. 80, 60, 60. I computed 3 days. In all of my empty times. For 35, I'm so sorry. Where is it? It's not important, you know? Yes, I have. Here. Cosine 35 here. What? 0.819152. Okay. We know C. Now, $238,650 multiplied by cosine 0.819152 equal to 195,490.6248 kilometer per second minus C. It's equal to 104,509.3752. Okay, now we will find that n equal to divided by